Hey everybody. I hope you're doing well in these difficult times. Thanks for coming to my session. My name is Mikolaj Pawlikowski, and yeah, it's fine. You can call me Miko. Everybody does. I am a software engineering lead at Bloomberg. I run a little team of SREs working on Kubernetes. And I'm also the author of the Chaos Engineering book from Manning that hopefully by the end of this session you will want to read. The session is on chaos engineering, and I'm going to try to use the next 20 minutes or so to convince you that it's no longer a gimmick and that it's actually time to kind of jump on the bandwagon and see what benefits it can give you, especially in the context of incident management. Like this expo. So the plan for the next 20 minutes or so is the following. We're going to start by getting everybody on the same page about what actually chaos engineering is. And then we're going to talk about what it isn't. Some chaos engineering myths that just refuse to die, and I kind of hear them every day. And, makes my blood boil a little bit, but this is how it is. So we're going to cover some of that, and hopefully that will convince you that these things are not necessarily what they look like. And once we've done that, I'll give you some tips on how to generate the initial buy-in, and hopefully, alleviate any friction that might be there at the beginning. Since we're at it, I'm also going to jump through some tools for you, a little bit, a quick overview to get you started, point you to the right direction. And I'm also going to talk about chaos engineering for people, which is kind of like both a buy-in generation tool and also kind of like a tool to introduce that to your team in a nice human manner. So if that sounds like a plan to you, let's go and do it. Let's start with the definition. So if you go to principlesofchaosengineering.org, sorry about that, you will find the kind of what I consider a canonical definition of that. So chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. If we just remove the fluff out of that sentence, we're left with this: experimenting to build confidence to withstand difficult, turbulent conditions. Okay, so this is really kind of important to get right, because a lot of people, we'll cover the myths, but a lot of people have this kind of grandiose ideas, but at the core of it, chaos engineering is really simple. We do experiments to be more confident that our systems behave the way that we want them to, or at least they behave the way that we think they would behave in presence of failure. Okay, so this is it. Like, this is literally the definition that we're going to use. What chaos engineering isn't is equally important. So chaos engineering came about from the good folks at Netflix, who had this idea to kind of release the chaos monkey so that it randomly smashes things and detects things that they didn't think, they didn't catch through other ways of testing, right? And this is kind of, at the same time very cool, because that made a very good blog headline and got people excited about that, because it's kind of unorthodox, unusual to do that. But at the same time, it's also kind of haunting us ever since, because everybody's thinking, okay, so this is just chaos monkeying stuff, like it's breaking things randomly, breaking things in production. So this is like the 5 top myths that I just keep hearing over and over again. For everybody who has heard about chaos monkey, but doesn't necessarily, didn't necessarily dive in to understand a little bit better about what the thing really is about at the end of the day. So, typical chaos monkey, right? Well, no, not anymore. It has matured since the chaos monkey days, and it's turning into this kind of scientific method of approaching the systems, whether they're big or small, and we're trying to basically turn it into a series, potentially a little bit more boring than the initial one, methodology. And this is like part of what I'm trying to. I'm going to cover a few things that I cover in my book, and if you're interested, there'll be I'll put the link at the end. But this is like one of the main goals that I'm trying to achieve with that book is to show you that using simple examples that this applies to a lot of things, to big and small systems. Like, one of the myths is that it's only for massively distributed systems. Oh, I have systems even. And that's not necessarily the case. Sure, these are use cases where things really shine through. If you have, a massive spread microservices kind of setup, there's a lot of complexity that chaos engineering can help with. But at its core, it's not limited to that at all. If you, one of the examples that I kind of go into in my book is I try to show you that you can do that, apply the same methodology even to like a single process. So one of my chapters is about taking a binary, some kind of server that you don't even look at the source code of. You just know that it's supposed to be handling errors in some kind of way. And in order to test that it does, you can treat it as a kind of black box situation. And by injecting a little bit of failure, in particular there, we're blocking some syscalls to see that it retries the way that we expect it to retry. And the same methodology, boom, applies to a single process on a single machine that's not really going anywhere. So it's not only for massively distributed systems. Sure, makes for nice blog posts and presentations, but it applies to pretty much, it applies to any system on any size or shape. So that's the second myth, right? Third one is the testing production thing, and this is kind of like interesting one because it's again kind of unusual aspect of chaos engineering, but at the same time kind of shooting ourselves in the foot when we're trying to spread the good word about it, is that a lot of people think that it's not chaos engineering if you're not doing that in production. And that's not true. There's no reason to not apply the best practices, the same practices that you apply for releasing your new software, to the new software that you release when you do chaos engineering, to the experiment that you do. Sure, the holy grail is testing production, right? The kind of chaos testing production, because if you think about it, by definition, only production is production, right? So that means that only the data in production, well, if you try to replicate, everything else is an approximation. That's basically what I'm trying to say, right? Sure, that's the case. The data will be slightly different, the usage patterns, users, we can simulate, we can spend a lot of time trying to simulate this as well as possible, but at the end of the day, it's going to differ. And some of the slight and possibly subtle variations are going to affect the end result of the testing. But that doesn't necessarily mean that we shouldn't test on these things too, on these environments. So it's a myth that if you're not doing it in production, it can't be called chaos engineering. It can, and it would be reckless to do something like that, as reckless as it is to release code to directly to your production environment without going through whatever QA stages that you have, right? Another one is that it only works with a particular technology. Well, no, it's a methodology. It's not linked to any particular tool. It's not limited to just Chaos Monkey or just the cloud or just a particular cloud provider. It's a methodology that is kind of a level above all of that. As soon as it clicks in your mind, you can apply it to whatever is relevant to you. And then another one is the kind of goes back to Chaos Monkey. Chaos Monkey initially was breaking things randomly, and it's an interesting kind of use case for chaos engineering. It's kind of like goes a little bit towards the technique of fuzzing, when you kind of generate all these random combinations of inputs so that you can potentially detect something that you didn't think of. And it's great. It's a good starting point. If you don't have any idea of where to look, it can potentially uncover some cases for you, and it can literally give you free bug detection. But it's just one of the cases. It's just one of the things that we do with chaos engineering. And from my experience, most of the time, it's about very deliberate practice of designing experiments that that require good understanding of what the system is, and figuring out where the potentially fragile elements are, identifying them, and then experimenting on them to verify that the system behaves the way we think it behaves. So sure, yes, randomness is a quite potent tool, but it's no, by any means, by any stretch of imagination, just the only use case for chaos engineering. So this is like the top 5 that I just keep hearing over and over again. There's obviously more, but just wanted to give you, for completeness, the definition by itself is nice, but then it's kind of like this this stuff around it that kind of points you to the right direction of what you can do with the chaos engineering. So assuming that I only have like 15 minutes left, so let's assume that I convinced you that there is some benefits that you can get from chaos engineering. The next question is obviously, how do I get the initial buy-in, right? There are the SMIFs. It sounds a little bit risky. It's a bit unorthodox. So what do I do to if I wanted to introduce that to my team? And I found that from like the user from like the team's perspective, especially for the SRE kind of teams, it really is all about getting code less, and everything that helps with getting code less is good. Everything that makes me wake up at night when I don't wanna less is good. So this is like a good starting point as a tool that people can use to achieve that, right? But from the kind of your management or your boss kind of point of view, it's all about the risk and reward, right? And this is where you need to be kind of prepared for the different questions if you want to start doing chaos engineering, because it sounds risky, right? If you just think about it, even if we had a bug, do we really want to uncover that bug that wasn't caught by other things if we can potentially get away with not catching it at all and maybe running for years, maybe even the lifespan of that particular piece of software undetected, and nobody's the wiser, right? And I find it interesting because when you start thinking about like the risk and reward kind of thing, you realize very quickly that we are pretty bad at estimating the risks and rewards. And we have all this evolutionary baggage that makes us overestimate certain risks and underestimate other risks, and we have hard time putting numbers to things. And one of the illustrations that I really like bringing up about is that if you go in the street and ask a random person about how likely it is that they're going to die of a shark attack, or how scared should they really be of shark attacks, you're going to be surprised. Like, mostly because of the fact that people watched the movie Jaws, people are going to very grossly overestimate the danger that is to do with getting bitten by a shark and potentially dying. And there's no really well, it's just not the case that they should be as scared as they are about that, right? Because if you actually take a look at things, some statistics, get some raw data, and try to compare, how scared people are about the other things that actually do kill people. Take a look at this heart disease. Over 640,000 Americans dying of that every year. Cancer, accidents. Nowhere in this list are you going to see the word shark. In fact, there's going to be so few of them that you are going to be hard pressed to actually find the numbers, and they're pretty low. So this is just to kind of illustrate to you that unless we put some numbers to these things, it's really hard to see what is a bigger risk. But even if we just do a little bit of, back of the napkin kind of math, and we just put some very rough numbers to that, the picture might become much clearer than it initially looks, right? So this is like one of the things that you need to keep in mind when you're dealing with this kind of stuff. Another thing that is worth knowing in the context of chaos engineering is this thing that we talk about that's called blast radius. And this is another really powerful tool when you're trying to generate a buy-in, because it sounds risky, injecting failure, injecting chaos into your system. You're going to often hear things like, oh, don't we have enough chaos already? And one of the tools that we use to limit that is just limiting the blast radius. Blast radius defined as the number of things, the amount of stuff that can be affected by that experiment, right? So obviously we can do better or worse job of estimating the blast radius and then actually following through with that. But for most experiments, it's going to be fairly straightforward to estimate the maximum, number of services, clients, percentage of traffic that we're going to affect with chaos engineering, even if things do go wrong, right? So the same engineering principles as we apply everywhere else also apply here. And if we, from the beginning, try to stay very vocal about the fact that we're trying to control this blast radius, and this is one of the goals that we're trying to achieve. This is a good one to generate and kind of like oil that friction that comes from the word chaos introduced to a system. Okay, so this is 3 tools that you have. And another one I wanted to give you is the kind of unusual, a little bit aspect of chaos engineering that I picked from Dave Renson at Google. And it's about looking at teams the same way that we look at software systems, right? If you think about that, when you have individuals inside of teams, it's very much like computers inside of the network. They have their independent clocks, they go execute their tasks, they have to communicate, they miscommunicate, there are bottlenecks, there are all kinds of things that are pretty much exactly the same. It's just, the speed is a little bit different depending on the amount of coffee they had on the day. So I found it very insightful to have a think about that, because even if you have hard time selling this to like a manager or a boss or someone who has to okay it, if you illustrate a little experiment that you can do with a team, you might have a easier time selling this to them. And also on its own, it's also a very powerful practice, because once you reach the level of maturity that when you're confident to inject some kind of failure into the actual team, when you're confident enough, there's probably no point doing that if you know that it's going to break it. But if you're confident enough that you can inject some kind of failure, like for example, ask someone to be slow, or ask someone to purposefully modify information so that you can see that the team as a whole can correct that, right? That the system is self-correcting. you end up with this games slash experiments slash things that you can do for your team and make it, make people more kind of conscious about this kind of thing, like bottlenecks and the speed and dependencies and single points of failure in the side of the team. And also, it makes for a really nice kind of team building exercise and a good tool to generate this initial buy-in. So chaos engineering for people as chapter 13, the last chapter in my book. Really recommend giving it a little bit of a go. Okay, so running out of time, I'm going to cover very quickly, if you're interested in getting the actual tools that you're going to need to apply chaos engineering. I have a little list here. Especially, I recommend checking the awesome chaos engineering list. This is the link at the bottom here. It has a roughly up-to-date list with different tools, different books, presentations, and links like that. So this is a very good one to follow. And otherwise, here's a little selection of tools. I would like to stress that a lot of what we do with chaos engineering is done with like the standard tools, the tools that have been there forever or almost, and especially in terms of like observability. But it's also nice to have these dedicated tools that kind of wrap them up in easier to use wrapper. So Shameless Plug, Powerful Seal is a chaos engineering tool for Kubernetes that I had the pleasure to write. Chaos Toolkit is another good one, a little bit more generic for describing experiments and running them. There's Pumbaa. Pumbaa is a tool for Docker that makes it much easier to apply some basic experiments to software running in Docker. Proxy, that's the monkey holding a banana. It's a nice programmable proxy that you can inject in between the software, the pieces of software that you run. And that will allow you to inject things like failure or like drop rate or like slowness and stuff like that. Very easy to use and allows for a lot of the networking experiments implementation. Chaos Monkey probably doesn't need an introduction. There's also Byteman that I wanted to mention here. That's the little thing here. That makes it extremely easy to inject code into JVM on the fly. So if you want to trigger like an exception, or if you want to modify some kind of class without actually modifying the source code, you can write little scripts with Byteman that allow you to do exactly that. They literally make it too easy. JVM is a massive deal still. So it's a nice skill to have. And then finally, well, you can see it here. You have a little screenshot that you probably recognize coming from KubeDoom. If you need like a party trick and you want to show people that it can be fun to run these experiments, it's a good one, a good icebreaker. You can basically, it wraps open Doom and you can shoot pods in your Kubernetes clusters to kill them. So pretty interactive and a nice one to have. And finally, this is my book. This is what it looks like. This one here. It's available in the early access online. It should be in print by the end of the year. If you go to manning.com/book/chaos-engineering, you found it. Like I mentioned before, I try to cover a lot of stuff in there. I try to cover different chaos engineering use cases, ranging from blocking a syscall for a single process through injecting stuff in JVM to verify that, for example, some kind of exception is handled the way you expect it to, and the retries are done. I cover injecting things in JavaScript on the UI. I cover Kubernetes, I cover Docker, and actually, the underlying technologies that make up Docker if you want to build your own or better understand it, application layer, and a bunch of other things that you're going to need to do chaos engineering. This is basically like a technical book right now. Basically, it's a technical book. Right now, the existing books from O'Reilly are much more about the kind of theory. And so this one aims to be like a hands-on book that gives you all the tools that you need, all the methodology you need to design your own experiments and go through with them. So give it a try. Tell me what you thought. And if you want to reach out to me, this is probably the easiest way. This QR code should send you to my LinkedIn profile, and you can reach out to me. I've been curious if it works. And photo credits. And finally, if you like the sound of what we're doing here, we're hiring. If you go to www.bloomberg.com/careers, check out the roles that we have. We do a lot of cool stuff, and we do more and more of the SRE kind of stuff, and more and more of chaos engineering. So if that's up your lane, please do join us. And with that, thank you very much, and stay safe.